So here's problem number 3 from section 5.1. Particle starts at 0 and moves along the x-axis with the velocity given as t squared plus 1. Where is the particle at t equal 4? Approximate the area under the curve using 4 rectangles of equal width and height determined by the midpoints of every interval. Okay, so as I map this out, here I am at 0. I'm going up to 4. Here's 2. Here's 1. Here's 3. Not drawn to scale. All right. It looks to me like at time equals 4, we're up at 17. All right. And at time equals 0, we're at 1. So the curve looks parabolic, something like that. All right. Now, it's going to ask us to use 4 intervals, and so each interval will nicely be here, 1, 2, 3, and 4. But since we're going to use the midpoints, our midpoints are going to be here at 0.5, 1.5, 2.5, and 3.5. So our first rectangle is going to be 1 wide, and it's the height. The height is going to be dependent on the value of the function at 0.5. So we're going to do again MRAM. We're using 4 intervals, and the first interval, the first rectangle is 1 wide, and how tall is it? It is 0.5 squared plus 1 tall. Our second rectangle, maybe we should do these in different colors. Our second rectangle is going to be 1 wide. And how tall is it? It's 1.5 squared plus 1 tall. Our third rectangle, again, sorry that the drawing is not very accurate, which is silly because I'm on a big piece of graph paper. I could have easily made this nice, but I didn't. The next rectangle is 1 wide, and how tall is it? It's 2.5 squared plus 1 tall. And then we'll go back to green for the last rectangle. The last rectangle is 1 wide, and it is 3.5 squared plus 1 tall. Now, if we go and actually do the work here, 1/2 squared is 0.25. 0.25 plus 1 is 1.25. So there's our first rectangle's area. Second rectangle's area, 1.5 squared is 2.25. Plus 1 is 3.25. The next 2.5 squared is 6.25 plus 1 is 7.25. And then the last one, I do not know what 3.5 squared is. 13.25 plus 1 is 14.25. It's 12.25 plus 1, so 13.25. So, looks to me like I got 4 quarters, so that's going to be an additional 1. So 1, 2, 5, 12, 25. Okay, now we're not done. Because 25, this problem happens in context. Oh, they didn't give us a unit, any units. They didn't say t is in seconds. They didn't say that velocity is in centimeters per second or anything like that. So our distance traveled is 25 units, whatever that is. Okay? That the area underneath the curve of velocity is distance traveled. Or actually displacement, sorry. Is that all right? Is that clear? Okay, great. All right, that's problem number 3.